about the preparation of aldehydes and ketones. Now today I will start to discuss some very important in-text questions on page number 356. The first one, I am only writing the answers here. The first answer is propyrophenone and out goes HCl. In the second one, we get the product 1-phenylpropanone and cadmium chloride. In the third one, first we have this product which tautomerizes to give you propanone, that is ketone, also known as acetone or dimethyl ketone. In the last problem is based on Itard reaction. We have discussed this Itard reaction. Now in this Itard reaction, the reactants react. You know what are the conditions. The first thing is the formation of a chromium complex, and this chromium complex finally gives you para-nitrobenzaldehyde on acidic hydrolysis. So this is the product is para-nitrobenzaldehyde. All these 5 problems are very important. I request you to practice them daily. Now, coming to the physical properties of aldehydes and ketones. What are the physical properties of aldehydes and ketones? You know, the first one I can say, I have told you, and I will discuss this in points. Methanol is a gas at room temperature. What is methanol? The first member of aldehyde family. The formula is HCHO. Number 2 point, ethanol is a volatile liquid. What is ethanol? This is CH3CHO. Other aldehydes or ketones are either liquid or solid at room temperature. Property number 4, the boiling points of aldehydes and ketones are higher than hydrocarbons of comparable molecular masses and ethers. What is the reason? This is due to very weak molecular association in aldehydes and ketones. What is the reason for this weak association? This is due to very important point here, dipole interactions. Coming to point number 5, the boiling points of aldehydes and ketones are lower than that of alcohols due to absence of intermolecular hydrogen bonding. Remember, alcohols have got maximum and intense intermolecular hydrogen bonding, which is absent in aldehydes and ketones. Now, after this, the next property I will tell you, here is a table. Please see here, the first is a hydrocarbon, normal butane, boiling point 273, molecular mass is 58. Methoxyethane 281, molecular mass is 60. Propanol 322, molecular mass 58. Acetone 329, molecular mass 58. Propanol 370, molecular mass is 60. What information do you get from here? Here you can say that alcohols have got maximum, the highest boiling point. Again, the reason being that they undergo intense intermolecular hydrogen bonding. These are somewhat lower because they go hydrogen bonding to a smaller extent, and these are much lower as here it does not show any hydrogen bonding. Now, the next point is that the lower members of aldehyde ketones, remember, the lower members of aldehyde ketones are miscible with water in all proportions because they form hydrogen bonds. Why do aldehyde ketones, lower ones, are miscible with water in all proportions? This is due to the reason that when they are mixed with water, they form hydrogen bond. This is the hydrogen bonding shown here, and this is the reason why some of the lower members are extremely soluble in water. Then, the next point, the solubility of aldehyde ketones decreases very sharply as the alkyl chain length increases. And remember, as the alkyl chain length increases, their solubility in water also decreases. Aldehydes and ketones are fairly soluble in all the organic solvents. What are the main organic solvents here? I must tell you, the main organic solvents are benzene, ether, methanol. They are benzene, ether, methanol, chloroform. In all these solvents, they are soluble. They are found to be soluble. The odors become less pungent. You know that aldehyde and ketones have got odors. These odors become less pungent and more fragrant. In fact, many naturally occurring aldehydes and ketones are used in blending of perfumes. They are used in blending of perfumes and flavoring agents. This was all about the physical properties. Thank you very much.